Hey, what's up? So I'm back, and today we're going to solve this question, exercise 1.8.3 from Shankar, The Principles of Quantum Mechanics. And yeah, I'll keep on doing it as long as people keep viewing it. Although no one watches my videos, I'll take it. Because this is so easy, solving these questions are pretty easy. Anyway, so this video is something special. Why? Because we have degeneracy here. Okay, in the first number 1 it says omega 1 is equals to omega 2 equals to 1. So that should mean that this whole matrix is a degenerate one. Like me, I'm a fucking degenerate, okay? Anyway, I'm not gonna talk about myself here because that's not relevant. Anyway, I might make a channel about degeneracy. Who knows? Anyway, so let's start solving. So we know that omega 1, omega 2, and omega 3 are actually eigenvalues, and this is an operator. So what we can do is, well, use the typical stuff. Oh my goodness, I fucking hate writing omegas. Anyway, so this is our v, our ket, or eigenstate, or eigenfunction, whatever you want to call it. Then we have omega as our eigenvalue, and this. Cool. So, I really wanna fucking punch myself because of this. Trust me. Okay, let's not forget there's identity matrix here because, well, that's a thing. Oh, because you can't just get eigenvalue randomly. You need something else. And this one is a null matrix. So we can just say that that's the case. Um, so what does this give us? Okay, so let's write down the stuff. What stuff? I don't know. So 1 minus omega, then 0, 0, 0, 0. Great. Then 3 by 2 minus omega, minus 1, minus 1. Then 3 by 2 minus omega. Sorry. Anyway. Yeah, cool. This is v and this is 0. Cool. Now what do we do from here? Well, simple. We can do something very good. Something that I'm very enthusiastic about. Okay? Determinant of omega minus I omega gives us 0. A very enthusiastic answer. God dang it. Cool. So let's just figure out the determinant of this fucker here. Right, so minus omega, 1 minus omega times 3 by 2 minus omega times 3 by 2 minus omega. Great. Let's not forget that we'll have to deal with these two here as well. So definitely. Oh hey, I forgot something. There should be 2 here because half it's multiplied, so yeah, I shouldn't be forgetting those kind of stuff. So if we multiply these two here, so minus 1 by 4. Great. This gives us 0. How about it? Fun, right? Of course it's not fun. Who cares if it's fun or not? It's all about mathematics. So 3 by 2. I mean, some people might think that it's fun, but I don't care. I have stuff to do. So we can just write it like this. Okay? Great. Uh-huh. So what we can write is, for 1, omega is 1, of course. Then what do we have here? I feel like I did not write it properly. Yeah, well, we can just write it like this. By 2 square, then 3 by 2 minus omega, plus minus 1 by 2. So this gives us, well, first for 3 by 2 minus omega equals to half, we get, what is it, 2? Yeah, it's 2. Probably, don't quote me on that. I might be wrong, but who cares? It's free real estate. I don't even know what free real estate at this point. It's like a buzzword. People keep on saying that, hey, it's free real estate. Hey, it's free stuff. Great. Anyway, this gives us 1 because this is fucking degenerate. Great. Right. So, what do we get here? Okay, no. This is 1. See? This is 1. I was wrong. We all can be wrong once in a while. So you can see that there are 2 omegas here. Again, not 2 omegas. We have 2 of the same value. So omega 2, omega 3. Hence, oh, I forgot to write something like this. This is number 1. Isn't that amazing, people? Pico? Ah, fuck it. So as our final answer, so omega, no, kill it with fire, something. Omega 1 equals to omega 2 equals to 1, and omega 3 is 2. QED. Nice. So we got rid of that question. Now what else? So number 2 is going asks us, what is it? Show that, you know what? Let's not go there. Shit. Right. So let's take some time to go over there and see what that question is. Okay, show that. Oh, okay, eigenvector of omega equals 2 is any vector of the form this. I don't want to say it out loud because I don't want to. Just don't. So what do we know here? We have omega equals to 2. For omega equals to 2. Great. Then, of course, we'll have to deal with that. We know that our determinant, again not determinant, we have this, right? Of course we do. So we'll just use this thing for our answer. And how can we do that? Of course, you know the drill. Just put in the fucking values and we'll get the answer. Of course we will. We always get the answer. If we don't, I don't make the video. I don't release the video, okay? So, yeah. Cool. So this is half and this is minus half. Cool. Times v. You know what? We don't need to write v like that. We can just write v1, v2, and v3 equals to get 0. Awesome. Now we can write it like this. This row times this column gives us something like this equals to 0. So this is 0. Cool. Also, this row times this column gives us v1 plus v2 equals to 0. Finally, something is not right. Something does not feel right here. You know? Oh, okay, so it's the same thing. Cool. Okay, this is great. Well, this thing also gives us the same thing. Oh, you see what isn't right here? It's because I wrote 1. I shouldn't have written 1. Okay, this is 2, v2 and v3. Always remember the number, people. If you don't, you're gonna get fucked really hard. So what if video coming up? I don't know. It won't. Anyway, what if V2 is 1. That means V3 is minus A. Okay, what if V2 is A? That means V3 is minus A, because you'll have to keep this thing homogeneous, okay? You'll have to keep it 0 PG. If that even makes sense. I don't think it does, but anyway. Let's continue. It's all shits and giggles until there is no giggle. And there isn't any giggle because I don't know how to make jokes. Anyway. So, right. So, we have to now normalize this whole thing. Let's not forget how to normalize stuff. How do you normalize? Oh, well, the way to normalize is, suppose we have vector v, then bra of v times ket of v. So it's obvious that we'll have to deal with some multiplications here and there. So we can say that this is actually our 0, v2 is a, and v3 is minus a. Then we'll have to multiply these things. Oh god, this is not good. This is horrible. So we multiply these things here. Excuse my bad handwriting for this moment. Okay, so what does this give us? This gives us 1 by root. Let's not go into 2 right now, because I want to make this video as long as possible. A square plus a square times 0, a minus a. And this gives us root 2 a. Or you can just write it like this. Whatever, it's your choice, it's your life. Yeah, cool. And yeah, so we got the answer. Okay, we showed these people how do you do things, how you do things. Nice. We're done with this part. Awesome. Now what do you do right now? Simple. We go back to the question and see what we need to deal with for the third question. For the third question, let's go. Whoa, I think I'm just gonna get rid of this part. Or maybe not. Hey, because stuff happened. Anyway, so the third question is, show that omega equals to 1 eigenspace contains all vectors of the form this. I don't want to say anything about this, trust me. I just don't want to call it whatever. Either by feeding omega equals to 1 into the equations, or by requiring that the omega equals to 1 eigenspace be orthogonal to omega equals to 2. Kept eigenvector of omega equals to 2. Okay, cool. So what are we going to do here? Simple, we're just going to do the same thing like we did in number 2. Why? Because it's convenient. There is another way of doing things. There's another way of doing it, I guess, but I'm not going to go into that because I am too lazy to do it. And I have my physics 3 or 4. Okay, I have my quantum mechanics assignment here, but I'm too stupid or too lazy to deal with that. That's why I'm making this video. Of course, do or make videos instead of working on your assignment. That's exactly what people do, don't they? Great. And then I'll get bad grades and mom will fucking beat me up with a sandal. That's how Asian people deal with stuff. Beat them with the sandal. Now, for omega equals to 1, simple. Our our omega minus I omega. Wow, I should just write it down. Big omega minus I small omega gives us 0, then 0, and 0, 0, and then 0, 1 half minus half, and minus half, and half. Great. Half is all you get for now. Anyway, so this is our answer. This is not the answer. but we can get close to the answer because we're fucking pros. Of course we are. If not, then you can go suck the duck. No, I'm not gonna say that. I shouldn't. Yeah, so technically or typically you solve so many problems that you end up becoming a mad lad without the lad part. I don't know why, but yeah, that's that. So how do you deal with this? V1 is arbitrary. Now, why is that? And I fucking got the spelling wrong. So why is this arbitrary? Because as you can see, there is no value for V1. Okay, so whatever you consider V1 to be, it's still gonna give us the answer because it gets multiplied by 0 and we get 0, so it doesn't matter. So we can just consider V1 equals to B because question requires us to say that. Anyway, finally, we have these two people here. So how to deal with that? We can just write one thing. So let's just write V2 minus V3 equals to 0. So it's obvious that these two values are equal. So V1 and V2 equals to V3 equals to, let's say, C, because the question requires us to say C equals to C. Now we have our values here. Now how do you deal with stuff like this? Simple. We need to figure out the eigenvector of this because our question requires us say or figure out this thing. I've been saying this a bit too many times. The question requires us, but it's just life and stuff. And you guys are probably pretty bored, and I don't even know if you're still here or not. If you're here, wow, amazing! Just subscribe to my channel and give this video a thumbs up because I don't even know why you're here and how you're here. But if you're here, great. And also comment down below if you have any questions or if you have any suggestions for the next videos. And yeah, that's the ad. Anyway, so let's wrap things up, okay? I just don't want to deal with this anymore. Right, where were we? Yeah, here. So let's just first write down the vector, unnormalized vector. So B, C, and C. Now you will have to normalize this whole thing. How do you normalize this whole thing? Simple. We know that BCC, big black, oh no. It should have, if it was BBC, things would have been way worse. And trust me when I say this, BBC is not something you wanna deal with. Not the British or whatever TV channel that is, or the tag in the Pornhub. Oh god, no. Demonetized. Yeah, so this is our normalized vector. I mean, technically normalized form. This is b squared plus 2c squared. QED. And we're done. Are we done? Yes, we're done. Great. Done for today. I feel like I spent much less time on this specific video. I don't know why, but it was very helpful. For if you found this helpful, then please do subscribe to my channel because, of course, subscribing is a good thing. Like this video because, of course, you wanna like my awesome videos. Comment down below if you have any questions, cues, suggestions, anything. Just comment down below and I'll be happy to read your comment and, well, let's just say answer to your comment because, well, that's just what I do. And yeah, that's it. So yeah, thank you all for watching this video, and like I said before, subscribe and like and stuff, whatever. And yeah, and I will see you guys in the next video. Peace out, goodbye, tata, and I'm out. Peace.